Welcome to the concept of perfect square, of perfect squares in quadratic expressions. Before we actually go into practical solving problems on understanding the concept of perfect squares in quadratic expressions, I want to draw your attention to something. I want to tell you that the square of the sum of two terms is always equal to the sum of perfect squares in quadratic expressions. I want to draw your attention to something. I want to tell you that the square of the sum of two terms is always equal to the sum of the squares of that number plus 2 times the product of the two numbers. The sum, or the square of the product, the square of the sum of two terms is always equal to the sum of their squares plus twice their product. I would like to explain this. For instance, if you have a plus b squared, a plus b squared, as I said before, that the square of the sum of two terms, the two terms now are a and b. Their square is the same thing as the sum of their squares, their different squares. That means a squared plus b squared, the sum of their squares, then plus twice their product, plus 2 times a times b. A times b will give you ab. That's exactly what I have explained here. That the square of the sum of two terms, a and b, their square, if they are adding themselves, is equal to the sum of their squares. The square of a, which is a squared, plus b, which is b squared, then plus twice their product. Their product is a times b, which is ab. Then twice of it is 2 of ab. I am going to go further to explain by expanding what we have here. When we expand, you discover that we are going to get this. And that gives us a clear confidence on this concept I have written on the board. If you are to expand it, that means you're going to have a plus b into a plus b. Of course, you know that is the meaning of this. A times a will give you a squared. A times b will give you plus ab. B times a will give you plus ab. And b times b will give you plus b squared. If you collect like terms, you're going to have, bring down a squared plus ab plus ab will give you 2ab. Then you bring down b squared. You can see that we have gotten back to a squared plus 2ab plus b squared. And that shows that our concept is very, very clear. Just like the concepts I explained before now, that the square of the sum of two items is equal to the sum of their different squares plus twice their product. In the case of the square of the difference between two items, it is always equal to the sum of their different squares minus twice their product. In the issue of the square of the sum, you add twice the product after adding their different squares. But in case of the square of the difference between two items, you subtract twice their product when you have added their different squares. What I explained is simply the square of the difference between two terms. Is always equal to the sum of their squares now minus twice their product. I'll explain this. Formerly we used a plus b. Now we are going to use a minus b, because that is exactly what the concept we are on is explaining. So if you have the square of the difference between two terms, our concept is saying that it is determined as a squared plus b squared, then minus 2ab. That is just what our concept is saying. Now I'm going to expand this, and we are going to see that it will give us this. When it does, that means our concept is correct. A minus b squared means a minus b into a minus b. A times a will give you a squared. A times minus b will give you minus ab. Minus b times a will give you minus ab, while minus b times minus b will give you plus b squared. If you collect like times, you're going to have a squared minus ab will give you minus 2ab. Then bring down b squared. You can see that we have the same thing we have initially. A squared minus 2ab plus b squared. That shows that our concept that the square of the difference between two terms is equal to the sum of their squares minus twice their product. Now let's go into factorizing perfect squares in quadratic expressions. Just like we have factorized 4u squared minus 12u plus 9. From the concepts I formerly explained, I told you that the square of the sum of two numbers is equal to the sum of their different squares plus twice their product. Having that in mind, ask yourself, which number is 4u squared? Its square. You find out that 4u squared is the square of 2u. Also ask yourself, which number is 9 its square? 9 is the square of 3. Write 3. Don't write any sign yet. Just write 3. Leave a gap where you put a sign. Now ask yourself, the product of 2u and 3 twice it should give minus 12u. So what are you going to put here to be able to complete that assignment? If you put plus here, it's going to be wrong, because the product of 2u plus 3 cannot be minus 12u. It is only minus that can do the job, because minus 3 times 2u will give you minus 6, and it's twice will give you minus 12u. So you can find out that factorizing that expression is 2u minus 3 squared. Let's check by expanding. 2u minus 3 squared means 2u minus 3 into 2u minus 3. 2u times 2u will give you 4u squared. 2u times minus 3 will give you minus 6u. Minus 3 times 2u will give you minus 6u. And minus 3 times minus 3 will give you plus 9. If you collect like times, you're going to have 4u squared minus 6u minus 6u will give you minus 12u. And you bring down plus 9. You can find out that you have gone back to the first concept you have. 4u squared minus 12u plus 9 plus 9. That shows clear that the square of the product of, the square of the sum of two terms is equal to the sum of their different squares plus twice their product. But in this case, that means the square of the difference between two terms is equal to the sum of their different squares minus twice their product. Factorize a squared plus 10a plus 25. This is also a perfect square. You know that a is a squared is a product of a and a. That means a squared means a times a. So write down a. You also know that the square root of 25 is 5. That means 5 times 5 is 25. Write the 5, but don't put any sign yet. You are going to put the sign between a and 5, considering the sign you have in the middle number. I told you the square of the sum of two numbers is equal to the sum of their different squares plus twice their product. Twice the product of 5 and a will give 10. That means 2 times 5 times a. 5 times a is 5a, then times 2 will give you 10a. Now ask yourself, is it, if we put plus here, will it give us the plus a, or is it mandatory we are going to put in? It must be plus, because it is only a times plus 5 times 2 that will give you plus 10a. If you put minus, a times minus a will give you minus 5a. And minus 5a times 2 will give you minus 10a, which is not what we have here. So that means this concept becomes correct when we write a plus 5 squared. I give you an assignment. Go down there and expand this and discover if you are going to get the original expression we have. Whatever you get, communicate me. Factorize x squared minus 2x plus y. The square root of x squared is x. Write x. The square root of 1 is 1. Write 1. Look at the sign that is in the middle. What is the sign there? The sign here is minus. That means what you're going to join x and 1 with should be minus. So that when you multiply x and minus 1, it's doubling it will now give you minus 2x. And that means the factorization of that perfect square becomes x minus 1 squared. Factorize 4 minus 4x plus x squared. In this case, first of all, rearrange this expression. This expression is supposed to take the shape of x squared. Writing this first, minus 4x plus 4. That should be the correct way the expression should go. The square root of x squared is x. Write x. The square root of 4 is 2. Write 2. Since the middle number has a negative sign, put minus and put your squared. This is the last question we are taking in perfect squares. And I want to go ahead and expand this expression to show you that you are going to get the original expression. X minus 2 squared means x minus 2 into x minus 2. X times x will give you x squared. X times minus 2 will give you minus 2x. Minus 2 times x will give you minus 2x. Then minus 2 times minus 2 will give you plus 4. Collect like terms, bring down x squared. Minus 2x minus 2x will give you minus 4x. Then bring down plus 4. You can find out that we have gone back to the original expression we had. X squared minus 4x plus 4 plus 4. The concept we are into now is the concept of difference of two squares. Why did we call it difference of two squares? It's because both x squared and 1 are squares of a particular number. For instance, x or x squared is the square of x, while 1 is the square of 1. As you have the minus in between them, that's why we call this concept difference of two squares. And if you have to factorize an expression that has the difference of two squares, it's a very simple thing. You just have x minus 1 into x plus 1. You have factorized it. The only thing you do is find the square root of the first term, put it in the first part of the brackets, find the square root of the second term, spread them, but you either put plus first and the next one minus, or minus first and the next one plus. That is the simple way of factorizing expressions that are in the difference of two squares. If you go ahead to expand this, you are going to get x squared minus 1. I'm going to do it. X times x will give you x squared. X times plus 1 will give you plus x. Minus 1 times x will give you minus x. Minus 1 times plus 1 will give you minus 1. If you collect like terms, you are going to have x squared plus x minus x. Cancel this. You have plus 0. Bring down minus 1. If you remove or simplify further, you find out that you are going to have x squared minus 1, which is exactly what we have in the beginning of the question. The second question we have in the factorization of different squares is factorize 4d squared minus 9e squared. Ask yourself, the square root of 4 is 2. The square root of d squared is d. In the first bracket, open the next bracket, minus and plus. You can say plus and minus. As we use minus and plus initially, let's use minus, plus, and minus. You also have d, 2d here. This 2d that I have spread into this is the square root of 4d squared. 9e squared has 3e as its square root. So you write 3e in the remaining parts of the brackets. Expand to check if what you got is correct. 2d times 2d will give you 4d squared. 2d times minus 3e will give you minus 6de. 3e times 2d will give you plus 6de. Then 3e times minus 3e will give you minus 9e. Sorry, minus 9e squared. Remember, 3 times 3 is minus 3, plus 3 times minus 3 will give you minus 9, while e times e will give you e squared. If you collect like terms, you're going to have 4d coming down the way it is, minus 6de plus 6de. They will cancel themselves and leave you with 0. So you have either plus or minus 0. Then minus, bring down 9e squared. If you simplify further, you will discover that you have 4de minus 9e squared, which is exactly what you have originally in the question. Factorize x squared y squared minus z squared. The square root of x squared y squared is xy. Put it inside the first bracket, open the next, you have xy again. It is xy that is the square root of x squared y squared. Now, z has the square root of, z squared has the square root of z. That means you're going to have minus z and plus z. For us to check, xy times xy will give you x squared y squared. Xy times z will give you plus xy z. Minus z times xy will give you minus xy z. Then minus z times plus z will give you minus z squared. Collect like terms. Bring down x squared y squared plus xyz minus xyz. We cancel and leave you with 0. So we have minus or plus 0. This can be plus or minus. Then minus z squared. If you simplify further, you find out you are going to have x squared y squared minus z squared, which was the original number that we had. Factorize 4h squared minus 25 is the last question we are going to be treating on difference of two squares. The square root of 4h squared is 2h. So write 2h in the beginning of the two brackets you are going to open. Very simple. The square root of 25 is 5. That means you have plus and minus 5 ending the two brackets. If you want to check, expand out the brackets. 2h times 2h will give you 4h squared. 2h times minus 5 will give you minus 10h. Plus 5 times 2h will give you plus 10h. Then plus 5 times minus 5 will give you minus 25. Collect like terms, you have 4h squared minus 10h plus 10h. They will cancel themselves and leave you with either minus or plus 0. Then bring down minus 25. If you simplify further, you discover that you have 4h squared minus 25, which is the original value we have from the beginning of the question. Now we are into the concept of using the principles of quadratic expression in solving practical problems. And the first one we want to look into is this question. Find the area of the shaded portion of the figure. The shaded portion is this figure, this side. From the figures that are given, it means that this is a square enclosing another square. This measures 28 cm, this measures 28 cm. That means this also place is 28 cm, this other side is 28 cm. This is 17 cm, this is 17 cm. That means this side is also 17 and this side is 17. That was why I said it is a square enclosing another square. So when you have this, we are going to use the principle of quadratic expression, just as we are going to do now. Watch. The area of the shaded portion is the area of the outer square minus the area of the inner square. And the area of a square, you know, is length times width. That means we have 28 squared, then minus 17 squared. That will give you the area of the shaded portion. The square root of 28 squared is 28. Inside bracket, minus the square root of 17 squared is 17. Open another bracket, you have 28 now plus 17. Remember when we were factorizing the difference in squares? If you have a number like this, just find the square root of the first number, put it in the first portion or the first sides of the two brackets you created. Find the square root of the second number, and whatever it gives you, put minus and plus of it at the extreme end of the brackets. If we expand this bracket now, we are going to get our final answer. But unlike when we have unknown figures like X or A or any of the alphabets, in this case what we have is figures which we can manipulate. That means remove 17 from 28, you're going to have 11. So we have 11 here, times, add 28 and 17. 7 plus 8 will give you 15. Write 5 and raise 1. 1 plus 1 is 2 plus 2 is 4. So we have 45 times 11. We are going to do the practical multiplication. This is 5. That is 1 times 5. 1 times 4 is 4. We have 5 and 4. You now add. Bring down 5, bring down 9, and bring down 4. That means the area of the shaded portion is 495 square centimeters. Question number 2. A man is 3 years older than his wife. If the sum of their ages is 73 years, calculate the difference between the square of their ages. In this case, we first of all calculate what the value of the age of the man and that of his wife is. We start by saying, let the man's age be represented by any letter. Let's use X. And let the wife's age be represented by, let's use Y. Now from the first sentence, they say that the man's age is 3 years, or a man is 3 years older than his wife. That means that X is equal to 3 plus Y years. If the man's age is 3 years more than the wife's, that means that man's age is the wife's age plus 3. Okay? Second sentence says, if the sum of their ages is 73, that means X plus Y is 73 years. Rearrange the first equation, because this is going to be the first equation, while this will be the second equation. This is now going to be a simultaneous equation. Arrange the first equation such a way that X and Y will appear in the left-hand side, and only a number will appear on the right-hand side. In doing that, you discover that you are going to subtract Y from both sides of the equation. And when you do, you have X minus Y is equal to 3. That will be the first equation. While the second equation is X plus Y is equal to 73. That is the second equation. Now, you are going to subtract equation 1 from equation 2. Subtract equation 1 from equation 2. X minus X. X, we cancel X. Then Y minus Y will give you plus 2Y. Will be equal to 73 minus 3 will give you 70. That means dividing both sides by 2. You're going to have Y is equal to 70 divided by 2. That means Y is equal to 35. So if Y is 35, substitute 35 for the value of Y in any of the equations to get the value of X. Let's take the first equation, which says X minus Y is equal to 3. If X minus Y is equal to 3 and Y is 35, that means X minus 35 is equal to 3. Therefore, X will be equal to 3 plus 35. Adding 35 to both sides of the equation to eliminate minus 35 from the left-hand side of the equation. X will now be 38. That's 8 years. This clarifies the fact that the man's age is 3 more than the wife's age, as the first sentence showed. Then if this is the ages of the man and the wife, 35 and 38, we are going to calculate the difference between the square of their ages. The square of the man's age and the square of the woman's age will now be 38 squared, 35 squared. Then using our quadratic principle, you're going to discover that the square root of 38 squared is 38. while the square root of 35 squared is 35. So we have minus 35. That's 8 plus 35. Subtract 35 from 38. 8 minus 5 is 3. 3 minus 3 is 0. Times, add 38 and 35. 5 plus 8 is 12. Or rather 13. Raise 1, 4, and 7. So what you have is 3 times 73. 3 times 9, 3 times 3 is 9. 3 times 7 is 21. That means that question that says that we should find the difference between the square of their ages. The difference between the square of their ages is 219 years. A golden washer has an outer and inner diameter measuring 14 cm and 6 cm. Find the area of the washer. Use the value 3.14 for pi. The area of the washer that the question is asking us for is equivalent to the area of the shaded parts. The question says that the outer diameter is 14 cm, while the inner diameter is 6 cm. The area of this washer, remember, this is a hole in a circle that makes the shaded part a washer. The area of this washer or the shaded part is the same thing as the area of the big circle minus the area of the inner hole, the smaller circle. Area of circle is calculated by pi r squared. That is the formula for finding the area of a circle. If that is the case, that means that the area of the bigger circle will be given by pi r squared, while the area of the washer will not be minus the area of the inner circle, which is also pi r squared. The only difference in the formula now is the radii, or the radius of the different circles, the outer and the inner circles. The outer circle now, which has a diameter of 14, has a radius of 7. That means the equation becomes pi times half of 14, which is 7 squared for the outer circle, minus pi times half of the inner circle, which will be 3 squared. Let's factorize this expression. There is pi here and there is pi here. Bring out pi. Let's see. Into 7 squared minus 3 squared. This has fallen into the law of difference in squares. That means what we're going to have is pi into open 2 brackets for the difference in the squares. You have 7 minus 3 and 7 plus 3. The square root of 7 squared is 7. The square root of 3 squared is 3. We are boiling down to pi into 7 minus 3 here we give you 4. Then times 7 plus 3 here we give you 10. This is giving us pi times 40. 4 times 10 is 40. Remember, they say we should use the value 3.14 for pi. That means our pi is 3.14 then times 40, which will give us, use a calculator, 3.14 times 40. It will give you 125.6. And that will give you the answer to that question that said that a golden washer has an outer and inner diameter measuring 14 cm and 6 cm. That you should find the area of the washer using the value 3.14 for pi.